Hey, hey. I'm here. Late start today. Had to mow the lawn because it's the only day of the week that it's gonna be like not stupid cold. Or hot, rather. It's gonna be hot AF like all week. Let's see. Let me check the weather. The Weather Channel? Ugh. 70 degrees today, but tomorrow is going to be in the it's going to be in the 80s for the rest of the week. It was really hot yesterday and the day before. So, yeah. It's like, might as well do it now, even though it's kind of wet. Not exactly the most enjoyable experience. But it worked. So, what am I doing today? Today, I've got the I've got my ESP32 setup figured out a little bit, I think. Now I can actually communicate with it and get data to it, like the code that I want to run. So, yeah, let me show you the... I think I have to fix something here. Hold on. No, it's there. Okay. Display. There it is. Okay, I fixed my setup a little bit and made it a little nicer. Unfortunately, I wish I had a way to, like, manipulate this camera remotely. Should figure out how to do that. But basically, if you can see... There. If I manually go in and wiggle stuff around, and let me show this actually a little bit more clearly. So I've added this new chip. You see that blue one on the left of the green one on the right side of the board? So I've got this device. It runs on I2C, it communicates with I2C, but it's a current sensing device. And so theoretically, I should be able to have code within the thing itself, like running on the actual ESP32, which is over here. I should have code on that should be able to communicate with that and monitor the actual current by itself, which is nice. As long as I can be connected to it, it should be fine. But maybe I need another device to do it, because otherwise, how do I communicate with it? Let me grab the FTDI thing. This might be a better way to do it. So I have this... I've had this for a while. I haven't used it on this computer, so it might not even work, but I think it should. Okay, so I have this FTDI device that is very neatly wrapped. I don't think I've ever used this. I must have had a different thing at some point, but basically, you plug this in, and it's UART, without providing power, which is the problem that I'm gonna have if I try to use the... If I just try to use USB-C to the thing like normal. That might be the way to do it. The other way to do it would be to grab another microcontroller and just plug it into that. And use that to measure. Yeah, I'm not sure what to do. Should have thought this through. Yeah, I don't know. Yeah, the other problem is these are tiny wires. These are just like small cables that I think they're stranded. It looks like they were just soldered on the end. Well, this is one way to do it. I think... it could work. I might... I don't want to, like, put back the display. That would be annoying. But let me take a look at this. So this is a... I'll do a search here. ETL 232RG VRE 1V8 WE. Yeah, this guy. Virtual COM port, USB FTDI. So if I plug this in, I wonder what I'll see. So there's that. Let me plug this into the USB down here. We'll turn that on. So that is the Violabs hub. Okay. And now I'll plug this in. That is the Future Technology Devices International Serial UART IC. Okay, so I think I can hook it up. Why not? Yeah, I'll try to use UART on this device. Let me see. ESP32S3. Development board pinout. Wait, what's this? What's this link? I don't want that link. I want it from the horse's mouth. Different mouth. Here. No? Not the data sheet. Ugh. ESP32S3 dev board. There it is. Pretty sure we have 1.0. Okay. U0. What? Oh, actually, maybe this won't work. So if this is... What's the logic level on these things? I never really learned that. Oh, you know what I can do? I can probably watch it with the logic analyzer. And use that instead. That might be easier. That way I don't have to figure out the logic level. I guess I can just go in. Where's the datasheet? Hardware reference? Nope. Datasheet. That's just this module. Let's see. Logic. Level. By default, USB serial. Technical reference. What? No. Give me the logic level. Bit value 1. Does it say? Probably electrical characteristics. Input power. No. DC characteristics. High level input voltage. I think that's what I want. So 0.75 VDD. Which is 3.3 volts. I assume. I don't think there's a data sheet for the dev kit itself. Possibly in the schematic. It can show us, 3.3 volts coming out of an LDO. So VDD is 3.3. So we have to hit 0.75 of 3.3, which is not 1.8. Yeah, 2.4 or whatever. So that's not great. So I can't use the FTDI thing anyway. Away it goes. This idea's a bust. I could still use the logic analyzer to snoop on something, on some kind of communication. So I can try to do that. Yeah, the problem is... maybe someone's run into this problem. ESP32S3 dev kit. UART, no power. How to enable output on 5 volt? No. Let's see. When I disconnect my external supply, the red power light is also on. I can program it. I can also access. My question is, can I power the ESP32 from the supply and connect UART to receive serial? Connecting the two supplies together is not a bad idea. It's not a bad idea as long as they're both actually 5 volts, and internally you shouldn't have a problem there. Yeah, you need to know where to look for it. What? Oh, no. I am looking at it. I don't want to... Ugh, I wish I would just be told what to do. Okay. USB to UART. I don't think this is entirely correct because the one I have is USB-C. But I don't think there's a way to prevent it from powering up via the thing. Let's see. Yeah, power supply programming. Both of them go through this LDO. I don't know if we can turn this off. Is the thing. Not without like permanently turning it off. That one's plugged in over there, so I'll take a look at this one. Let's see. One of these is some kind of LDO. I can't tell. Those look like transistors. There is a 0 ohm. It looks like there's a 0 ohm resistor in there. Not sure what it's doing. Let me... Is it this? VCC 3v3. Okay. Where the power at? Ow. Where the power at? So, here's the dev kit. Mostly. There's an LDO 3v3 out there. So, if these are... Come on, why can't it... I have to, like, release control before it lets me zoom in and out again. How strange. How annoying. Okay. Here's this. V-bus comes from USB, and that's up there to V-bus, and then it's also through this diode, the 5-volt supply. So then, same thing here. ESP, USB. Which one is which? USB DN. USB DP. Where do those appear? Over here. And is that distinct from GPIO 19 and 20? Because these go in to here, looks like, and out they come as U0RX and U0TX. Which is different from GPIO 19 and GPIO 20. So, are they labeled? They are. Okay, let me look at this data sheet then and try to figure out GPIO 19. That's more like what I'm looking for. USB PU. ESP32 USB PU? Okay, wait. USB PU pin. I don't actually know how USB works. USB. GPIO 0, GPIO 46, GPIO. Here's this big thing again. Well, we're saying 20, 19 and 20. Power up glitches? Chip PU. 2019 crystal power 19 and 20. Okay, USB pins. Everything you need to know. What do I need to know? Yeah, I mean, there's D- and D+. That I know. ID? That's a different pin. How does it use the other pin? Additional pin to support on-the-go connection. Is that for it to pin the other way? Okay. USB PU pin function. That's pull up. Well, let's take a look here. Pull PU. USB with the pull-up resistor. Okay, I need to understand how this thing works. Because right now it's just a blank to me. Like, there's 2 USB ports on it. What the heck is each one of them for? And why are they different? Right, that kind of stuff, that it annoys me that such a low-level device is like trying to abstract that away. And it's starting to frustrate me a little bit. USB on the go? Okay, that's not what we're interested. USB on the go, I believe, is when it's when it sort of acts as a host thing. I think. Basically, it's not the same. It's not the same. Let me look. Let's jump back to the table of contents. Search for USB. Here we go. USB serial JTAG. bunch of stuff. JTAG interface allows fast communication with CPU debug core. Okay. USB interfaces with an USB host processor on one side and the CPU debug hardware, as well as software running on the USB port on the other side. Interfacing with a USB host connection on the physical level is done with a PHY. I'm actually not sure what that is. PHY connection. It's probably short for physical, but yeah, physical layer. PHY connects a link layer device to a physical medium. Okay, APHY. Okay. USB. A PHY chip is integrated into most USB controllers. Provides a bridge between digital and modulated parts of the interface. Sure. ESP-S3 has an internal PHY, which is shared between on-the-go and JTAG serial. Okay, here's the block diagram. Host, I assume that means machine we're connected to. Somehow, connections, cable, whatever, to a PHY. Then, something that knows how to interpret these things and turn them into normal protocol level stuff. Then we got a bunch of whatever these are. Either one of these can use the internal PHY. Optionally, the signals from the unit not using the PHY can be routed out via the GPIO matrix to I/O pads. Adding an external USB PHY to these pads results in a second usable USB port. The actual routing from serial on the go to internal physical external is initially decided using eFuses, can be later modified with register writes. Okay. Oh, I have to take this. Hang on.
It's gonna be hard to do. It doesn't matter. It doesn't matter. Because what happens is Doesn't matter. It doesn't matter. Because what happens is
Hey. All right. I'm back. Whoa. My hair is going crazy. Okay. I had to take a phone call. All right, so where was I? I was in the middle of looking at this, the USB system here. E-fuses. Right. Okay, so does this mean that both USB systems can be used as ports? Let's keep reading. The CPU JTAG signals can be routed to the USB serial JTAG controller or external GPIO pads when the user program is started, software control as well. At that time, JTAG signals from USB can also be routed to the GPIO matrix. Allows debugging a secondary SoC via JTAG using the JTAG controller. Oh, okay. So I think that means that this chip can be used as a debugger for another chip. Is that what that means? Oh, and are these E-fuses up here? Allows debugging a secondary SoC via JTAG using the serial JTAG controller. Yeah, they can be routed via the GPIO matrix to a different CPU. Okay. The CDC ACM interface adheres to the standard USB CDC ACM class for serial port emulation. I need to look up what this is. Communication device class ACM. What is ACM? ACM. Because I abstract control model, because that's what shows up here, right? ACM 0 is usually how it shows up when it's plugged in. Abstract control model. You can typically use it in applications that previously used serial COM or UART. Yeah. So is that just something I need to understand now? Connect it to APB bus, interact with it, data sent to received. Okay. Mainly used to read and write data from and to virtual serial port on the attached host. Yeah. Firmware can get notified of new data. JTAG serial bit will remain 1. Okay, yeah, so some async stuff here. Send butter, trigger flush. Send buffer. Okay. Some JTAG stuff. I think we can skip over this. CMD rep usage. What is CMD rep? Ah. Command repeat when under JTAG. Response capture unit. Control transfer request. Okay, recommended operation. As the ESP32S3 only has a single internal physical thing, at first programming you may need to decide how that is going to be used in the intended application by burning eFuses to affect the initial USB configuration. This affects ROM download mode as well. While both USB on the go as well as the USB serial JTAG controller allow serial programming, only on the go supports the DFU protocol and only the USB serial JTAG controller supports JTAG debugging over USB. Okay. Now we're talking. This is exactly what I needed answered. There are two USB ports on this thing. One of them is connected via the USB on the go circuitry. The other one is connected via the USB serial JTAG circuitry. And there's some eFuses. Okay. So DFU, what is ESP32 DFU? Device firmware upgrade or update? Upgrade. Is there an S3 version of this? Yep. Firmware is flashed via serial port. Yeah. Also contains USB on-the-go peripheral, making it possible to connect to the host directly via USB device firmware upgrade. By default, now we're talking, the USB serial JTAG module is connected to the internal USB PHY, while the on-the-go peripheral can be used only if an external PHY is connected. Since DFU is provided via the OTG peripheral, it cannot be used through the internal PHY in this configuration. However, you can permanently switch the internal USB PHY to work with the OTG peripheral instead of serial JTAG by burning the eFuse. Now I'm getting it. Okay. Some cables are wired up in non-standard colors. Please try to swap cables. D+ needs to be in bootloader mode before it can be detected as a DFU device. Okay. So what is on the DFU? Is that just like low level stuff? Like super internal kind of things? Or is that something different? Well, okay. Um... Can we turn off JTAG debugging serial only? Working with this dev kit. You are correct. These are the JTAG pin, mistaken that they are occupied like this by default. You can easily reconfigure them using the same function calls to initialize GPIO. But then I can't see 3v3 when I set logic 1 there. Reset pin into No, no. Okay. ESP32. Serial port without power. Serial port available fails when device powered externally. Serial monitor problem. Platform IO. What? Arduino? No. Well, I've run into this. I think I run into this myself. Play around with these setups, get what you want. Yeah, this is Arduino stuff. I'm not Arduinoing. What's this? USB connected on pins. Yeah. Ugh, Arduino. Huh. Basically, I just want to not have it powered. Yeah, how do I communicate with it over USB but without powering it over USB? Yeah, you plug it in and you get 5 volts in there and bada bing. But that's not what I want. That doesn't work. That doesn't work for me. So, can do that. Sure. Prevent damage. Blah, blah, blah. Okay. What the heck is this? I want a board like that. I don't have a board like that. It'd be way useful. Well, let's see. No. What else is in here? There's a lot of stuff here. Some of this looks kind of cool. But I assume it's all, like, very Arduino-y. Let's see. Communication between two of these guys. I assume... Yeah, this looks like Arduino. Ugh. Well, whatever. Okay. What are these RX because there's these UX and RX pins that are on this guy. Where'd I put it? On the top right of this board, I see there's a ground, then there's a TX and an RX, and then pin 1 and 2. Now, I can't look underneath it to see the traces, but let's see. It's hard to tell. Might be on like a different layer. But basically, it looks like ground, TX, and RX. Ground, TX, RX. So pad 36 and 37 appear to be connected there. Then there's these vias here that are connected to what? Way down this way. Down here. Okay. So it's only 2 layers. Okay, so then back up here, connected to this. I mean, this isn't quite the thing I have, but it's really close. So it looks like... Are those... Is that a little jumper? That's clever. Okay. Not sure how that corresponds to the board I have, but... Yeah, that's... So these basically go down here and come out and connect to this. Which looks like... if I look at some of these vias down here, connected over this way to ground, I think is what that looks like. No, they wouldn't do it that way if that was ground. So just above the 21 hole here, those get connected up there, which are connected to this. Okay, Interesting. So these two, 37 and 36, was it? Yeah, 36 and 37 are these TX and RX for the internal USB, which come out of here, which are also connected DTR and DTS. Or DTR and RTS. With some magic here. Well, okay. I guess let me just try it and see what's up. I've been streaming for an hour and I haven't gotten literally anything done. And let me look at the code here as well. I have it pulled up. Main. I added this power monitor thing. Let me also fix. Let me get this plugged in properly, because the I2C lines are just hanging out. These guys, they're just floating. I think I need to fix the placement of the light. This is what you come here for. To watch me mess this all up. Okay. Alright, we have a real light overhead. I also gotta figure out, maybe move all my stuff so that the mic is on the other side, but we'll get there. Okay, so I have to fix these little guys. They gotta move. I got my little pointer. They have to move from underneath this over to. This is where I have the I2C broken out to. So we're gonna do some connections here. There we go. And if I look at the chip, it's V in on the bottom, and then we got data, and then clock going up. Shoot, that means they're backwards. Yeah, I think that's right. So, data and clock. Data is green. Where'd my sticky note go? Oh, did I grab it? I think I moved it somewhere. Like a fool. Hang on. I need that. Okay. Yellow is clock. I believe that is correct. And now I need to jump from there up to where it's broken out. I keep breaking it. Now it's too short. This song sounds like they're scratching. It's very weird. Disconcerting. I think feels like something's scratching at my door. Let me grab another one. It's gonna be good enough because my wire cutting skills are apparently really bad. Well, let me practice. I'll try to set the pliers. See that screw? You can adjust that. It looks like it's just a little too loose. Tiny bit. It kind of worked. Okay. Perfect. All right. Anyway, doing the yellow one. There. Perfect. Looks beautiful. Ugh. So those wires have to cross over. I guess I don't have to, but at some point they do. Now, I can try to power it, I suppose. There we go. So now I've got this probe plugged back in. And then I don't remember where I had the analog. Oh, it's already plugged in. Okay, everything should be plugged in again. I guess I could bring it back into the frame. So you can see the colors are a little bit more consistent, but there is this one yellow that is so hard to see. This one here. Onto there. It looks dark. How about now? Does it look yellow? There. That's the analog into the voltage splitter, or voltage divider. Okay, so theoretically, we should be able to have a power supply power this thing. And, oh, I forgot the wire that I had on the post broke. But actually, I need to use it. Oh no, I dropped it and it's tiny. So I rearranged the power on the breadboard. So before, the power supply was connected to the top rail of the here. See the rail? So before it was connected to this top rail. I say top, but it's on the right. So now I'm going to connect it to this side rail over here because the 5-volt supply from the MCU is connected to the top rail. So I want to bypass this post. I want this post, when I plug in a power supply, to bypass it so that it acts more like the battery. So I'll plug it in here. Then it'll go through this chip, which should measure the power, into the regulator, and it should come out at, or not 5 volts, but 3 volts rather. That's the 3 volt supply across the top. Make sense? So now I gotta get that supply. You cannot see the supply. How's that? Movie magic. Okay, so first thing I gotta do is plug it in. Second thing I gotta do is bust out my multimeter. I got it here. And what I'm gonna do, I have to measure the voltage output so that it's actually what I think it is. Because the little galvanometer deflection thingy it has on it is not very accurate. Oh, you can't read that. Traces of your lips linger on my waist. I don't wanna go, I don't wanna wait. I'm needing you. We shouldn't speak of this magic. We should just say what they know. Well, then I can't read it. I'm just gonna do this. Tell you how I feel tonight. I keep trying, but the words ain't right. Nothing's fitting for a kind like you. I'm never speechless when the earth's my fuel. Killing the time, building a fire, wrapped in each other as we fall in love. I've never met a girl like you. Never met a girl. There we go. Kind of see that. So it's supposed to be like a 9-volt battery. There it is. 9.0 something. That's what we want. So then I will plug it in. I'll plug in the ground. The ground is connected properly throughout the breadboard. But I'm going to use a different end for the positive. I'm going to use this clippy style banana plug. And I don't think I'm ever going to find the short little red wire I was going to use for this. Nope, it's gone. Let's see if I can find... There we go. They're tiny. There we go. We are powered on. But I don't think it's working. So I'm going to turn this off. Because the LED is like flashing, and that's not exactly the behavior we want. So let me make sure we can program this in. Why is the bitrate tanked? Ugh. It's fine now. No, 3000 kbps. It's been better. Let's see. Let me make sure the font is something you can read. And we got to take a look at where, when we're booting up, I'm going to see, can I do nothing except maybe the... maybe this LED task. Okay. Get rid of moisture sensor. Get rid of the bus. Power monitor, definitely. Ticking every minute. Even... let's get rid of that, too. All I want is pin 7. And this loop wakes every once in a while. No measurement. Don't need to do that. But we do want to print F. So every so often, just print F, hello world. So this is set to every minute. We'll copy that, but do it every 5 seconds. We'll do puts. And we can keep pin 7, but then we'll do pin 7 dot toggle. Yeah. So every 5 seconds we should get an LED blink. Hopefully. Let's try to upload that. So ESPENV is my alias. Can I set the font size here specifically so I don't have to guess? Profile. Font size. Mono. Regular. 16, so it matches there. And now it should match my Emacs as well. 16 or 14? I don't know. That's close. Close enough. Okay. So that should do that. IDF pi build. We're going to power it on. And we're going to do IDF pi. Key should be dev tty acm 0 flash. So I'm going to turn it on, but I think I'm going to put it into like the bootloader mode. So I'm going to hold down boot. And then I'm going to turn it on. Okay. And then, so it should show up here. Oh, there it is. So I should be able to flash it. Okay. And if I hit reset, pin 7 should wiggle. It's flashing very fast. IDF Pi monitor that port. No such file or directory. What? Okay. Let me pop up in a second terminal. So this is what I was struggling with before. IDF Pi flash port dev tty acm 0. What? Could not open. It's busy or doesn't exist. Okay. Menu Control T followed by Control H. Control R to reset. Control R to reset. Quit. Well, poop. Is my LED backwards? I don't think so. Let's see. LED orientation. So the flat end is the cathode. So it goes to the flat end. So that guy should just be sinking all of the current from the thing. So here it is there. This puts flush. F flush. Puts. Stud puts. Yeah, I don't know why that isn't working. IDF Pi build. IDF Pi P for port dev ACM 0. We're going to do build flash monitor. Waiting for download. Yeah, that's... What is that? ESP IDF. Waiting for download. Stuck waiting for download. Okay, maybe... Maybe I broke it. And that's why it doesn't want to... Like, it's not alive long enough to allow a connection. Right, this. Power on resets flat. It's not... We're not using SPI. Add a cap to enable an IO 0. Is that even on the... Is that even on here? Enable? Is that different from reset? I don't know. What is log? Maybe we can use some of these other pins. Yeah. Very disappointing. Broken pipe. Nope. No matter how many times I try, it seems like. Can I monitor flash? What happens if I do that? Yeah. Okay, so I think... Can I do... What is it? The DFU? Okay, build DFU. Hold boot, press reset. And then I think... Yeah, TTY ACM0 is still in there. So, DFU list. Wah. DFU flash. Can I do P ACM0? Ah. Have a look at the device firmware upgrade through USB chapter. What is this? No. No. Here. Stable. Also for S3. Yeah. Connect to that. However, you can permanently switch. I don't want to permanently switch it. Those should all be connected. Boot mode selection. Yeah, I've done that. I've done that. Is there a different UDEF rule for this? I thought I'd set this up. USB driver not possibly installed or UDEV rule not set up or device is not in bootloader mode. I mean, I thought I knew how to do that, which is you hold down boot while pressing reset. Yeah, that's what I want. GPIO 46 must either be floating or driven low. Okay, where's GPIO 46? It's this guy over here. Driven low? Let's ground that pin. $46. Okay. Have I done the procedure? Now. DFU list. Okay, cannot open DFU device found. Whoops. Cannot open DFU device found on devnum libusb error access. Okay. Missing drivers. Missing drivers. DFU drivers. Linux. DFU util. License. Is there... Okay, let's ask the AUR. DFU. It's right here. DFU util. Uh-huh. Okay, let me do this. DFU util list. Sudo. Let's do this. See, sudo DFU util list. Audient? Oh, that's not right. That's my audio interface. Let's see. Etsy udev rules. $40. Yeah, subsystems USB. A Tribs vendor. So what else is in there? Or in Etsy udev rules. In the Sele. Oops. Subsystem USB. Product mode group. I mean, what's the log? How do I view logs? Demessage. Right, here it is. Well, is that it? New USB device found. There's a serial number. Product 2. Oh my gosh. What have I gotten myself into with this? Let me see if I can watch the pin wiggle. Here, I need real probes. Okay, so it's at 1.86 volts. Versus 3.3 on the other side. So that's 1.4 volts across the LED. Let's power it off. And back on. Can we monitor? Oh my gosh. Finally. It's very slow though. This is strange. Does the code not actually work? Let me see. So it is repeatedly printing show chip info. Forever. Pin 7 toggle. So why is that not working? So that should be setting the level on and off, on and off. That's odd. Let me kill this. What the heck? I keep doing. I gotta add in that parameter. Okay. Well, now it's waiting for download. See? What the hell? Okay. Control T H. Control T, Control P. Pause app, enter bootloader mode. Control T, Control R to restart. Yeah, ESP waiting for download. This is some really annoying shenanigans. A simple Google tells me you have a few hoops to jump through. I would advise you to find out why this is like. That's why they're asking. I'm going to output some message by serial port, but I can't monitor it. It's yeah, exactly, right? I'm printing hello world and I can't see it. Oh, am I maybe an idiot or let's see. I'm not using like GPIO 19 for anything, am I? 19 and 20, no. Because those are the JTAG USB. And then we got 15, 16, 17, and 18. Which might be messing with the UART stuff. Oh, but 7 is this one, so no. Oh my gosh. One of these is UART and one of them is USB. USB and COM is how they're labeled on mine. Oh, brother. I don't know what to do. I'm really annoyed. That I can't even hello world this thing. I have a third one. Alright, what if I just unplug everything? Okay. Now I don't see it. Okay. And now I jump in to try to monitor. I have to remember to type the B. Okay. That's waiting for download. Build flash monitor. porting. I'm adding dev tty acm 0. And it's this. GPIO 9 is a special pin. Oh. Chipper's crapsed. I don't see what I could be using that might screw it all up. I know I'm using... Well, I'm not even initializing any of these things, so it shouldn't be doing anything. Init NVS. Show chip info. This is doing some clock stuff. And then I'm initializing GPIO pin 7. There. And that is basically it. I'm saying save the time, give me a constant value here, delay for a while, print hello world, flush the output. Well, let me try flushing before entering the loop. Toggle the LED, and then it should loop back around, and then it should never get here. Okay. ESP error check. What do you do? Error check failed. Is a function. I want to find that. There. Components. Check failed. ESP error check failed. Here. It just calls abort. Damn it. All right. So that ain't it. He's also saying GBO 9 was bad. I mean, we're just using 7, and that seems to be too much for it. Let me find it. I guess that's what I get for buying like an off-brand thing off of Amazon. What? Oh. This is a development kit that doesn't really have any additional information. I mean, it could be that I have messed it up with configs. So maybe I can go into there and fix that, but why does it work with the other USB port? That's what's getting me most confused, right? Like it shouldn't work with one and not the other. Right? So there's that. So does toggling not toggle? It does. So now it's 3.3. And now it's 0. And then it prints. Yep. It should go up. There you go. Should go down. After 5 seconds, back up. And back down. And up. There it is. And down. So why if I switch this over, does it not do the same thing? Okay, now it's running. Okay, it's running. But I'm not able to see it. There it is. Okay. What if I just monitor? It's up. It's down. Broken pipe. Okay, maybe I just shrug my shoulders and say it's black magic and be annoyed at how I just spent the whole stream on that. It's only been 2 hours. I did start kind of late. Whoa. I guess I highlighted something on Amazon as I was looking at the product description to see if maybe there was a link to a datasheet or something. I don't know. Yeah, I don't know. Maybe I'll see if I can get some official boards instead of these knockoff ones, and I might be able to get more. A little bit more direct, like how the heck it works. um... Yeah. Okay. Don't have too much longer here. Ooh, there's a new can opener video. Those are great. Okay, so it's like working. So I suppose maybe I just won't use that port. Let's plug everything back in. All right, I think I'm plugged in. There. Boosh. Every 5 seconds it turns on, every 5 seconds it turns off. All right. Oh, man. How disappointing. Okay. Now let's put this all back. And now everything should be quote-unquote working. Bring it back here. See, now it's blinking really fast. So the LED toggle task is supposed to be every 5 seconds. Connection reset by P. Oh, wait a minute. Okay, if I start my, let me open a new thing here. Into the Compost serve. Run the Phoenix server. Excuse me. Error loading. Could not start hex. Try mix. Local hex. Yes. I'm still confused by the behavior of the LED. It should toggle every 5 seconds. Okay. Now is this working? Hmm. this is every 30 seconds. Can we reset it? Write all the stuff? Okay. What? Why doesn't that work? I guess maybe it wants to be like a global object or something. So this is I'm giving it the address of, right? So this is this value is a GPIO pin star. I'm casting to a void star. I'm taking a GPIO pin star and then dereferencing it to get GPIO pin ref. And then what's supposed to happen is that every 5 seconds, this should wake up and toggle P7. I2C transaction failed. With what? Oh. Using calibration value. Okay, that doesn't actually write anything. So that shouldn't be doing that. So let me try this again. Uh-huh. So it should. I mean, this toggling thing is really getting me, because that's not supposed to happen at all. I mean, it should just toggle once every 5 seconds, not flash like that. Let me see. So if I do this, just hit it with the, whoops. Stood puts. Toggle. Flush. Stood out. Okay. Before I even get to the calibration thing, let's print that out. Oh boy. I don't get it. All right. Hold on. Can I... Okay. Let's go... Whoops. Let's go directly in there. Stood. Print F. C Studio. We're going to print F that setting pin. It's got a number, 2, and then a number. So pin number, which we do not save. No, we do. It's called pin. We use it here. And then we set it to is high. We'll say writing pin %D to %D. Okay, close this. Build flash and monitor. Some new output here. Yeah. Some new readings. That's fine. Not worried about that. Here we go. Let's go. Okay. Error. Stack overflow. Hello. Hello world. Now that's what I'm talking about. Why Stack Overflow? All right, maybe I'll get rid of the... Maybe I should get rid of the puts and flush in here. Stack Overflow. Does my theoretical viewer understand what that actually means? I assume everyone knows what Stack Overflow means. All right. Okay. I guess it's just a question of like why that happened is probably it just happened at the wrong time. And it might be using a new kind of stack to do the work there. But now we have a problem. If it's not flushing, then I'm not ever gonna see. I'm gonna see it at some indeterminate amount of time after, which is not what I want. There we go. Maybe I would actually see some of the LEDs on that thing blink. How's that? Yeah, so you can see the LED flashing. It's not what I want. Oh, I didn't put new lines in it. That could also be part of it. Could it be just browning out the supply, you think? Well, I do have this box. Let me show you the workbench. I have this box that I bought online. Just kind of neato. Yeah, check it out. It lets you just swap with the turn of the knob the values of resistors and play with it that way. I wonder if we can take it apart and look inside. How about that, huh? So it just like adds resistors into a chain. So that's 9 ohms being added to the end there. It's like a short... That's cool. So we can play with that. Hey, these aren't actually banana plugs. Boo. That's annoying. I assume these would be banana plugs. Well, resistors don't have a direction, so I'm just gonna clip onto these with like alligator clips. I had a box. With a bunch of stuff. Oh, are these all? Oh no. This box is not what I thought it was. Shoot, what'd I do with the little post screw things? They vanished. How did I manage that? I just had them. I see them. They've gone beyond the end. At least one of them did. Found one of them. I can't see the other one. Got it. Just need a longer wire here to be able to plug this in. Strip. Let's test it with a multimeter, shall we? Grabbing the multimeter. Can't see it. Kinda. Okay, looks like it works. And we're trying to replace this, which you can probably barely see at all, with our thing. So what is this measuring at? 68 ohms? So that's it at 68 ohms. What if we just double that? So that should be 100 ohms in there. Even higher? That's a mega ohm. Now it's much dimmer, but it's still... I'm still getting all that flashing going on. And I don't understand why. So let's try powering it again. With the supply. Nope, still flashes. Yeah. I don't know why that could be. I guess I could pull out the oscilloscope. Now, you definitely can't see this, but oscilloscope has been pulled out. Okay, I'm clipped on to the GPIO end. Trying to do the trigger levels on here. Maybe I can move the camera. Hang on. That was almost a true catastrophe. Okay, I think that's good enough. Oh no. The orientation. I don't think that's gonna work. Okay, that's fine. That probably works okay. There. Okay. So I'm trying to figure out what the heck is going on here. Why is it flashing like this? So when it's low, it's like weirdly like... It's flashing. It shouldn't be flashing. Right? If I unplug the resistor, now you're seeing what I expect. All right, so it's at 0. And then it starts... But it's like... It's flashing. Why is it... Yeah, it's pulsing. Like, why is it pulsing? That's what I don't get. Okay, so that... LEDs on pin 7. I'm going to dive into... Oh, right, I unplugged it. So... Pin 7... happens to be the 7th pin along here, which is connected probably over here. Yeah, 1, 2, 3, 4, 5, 6, 7. Up. Seven goes up right by pin 4. Here. Pin 7. I mean... yeah. I don't know what the heck is going on there. Pin 7, GPIO 7, GPIO 7. Should only appear in the one place, here. But then it's also on this page? Nope. Now what is it highlighted? It might be like background. Some background stuff here. Okay. So, looking back. Don't need that. 7. It makes no sense. It makes no sense. There. I've clipped onto the pin directly. Nothing else plugged in anywhere. And it's still... This GPIO 7 on the module that I have is behaving like you could see in the thing. There. It's flishy flashing. With like a weird... With like some kind of weird pulsing. It makes no sense. There it is. IO 7. Pin number 12. Oh no. Hang on. That's not how it is in the schematic. Pin number 12 is not IO 7. At least I don't think so. GPIO 7. Wait, what's the difference between these two things? This is the reference design of the module. For modules with PS RAM, SPI voltage is blah blah blah. Other modules ensure 45 is not pulled high when the module is powered up by the external circuit. Uh-huh. Here's IO7. What's the difference between these two? Is this inside this? Or is this inside this? Yeah, what? This is the whole shebang. Bother. Glitches during power up. Not what I'm... Let's see. ESP32S3 GPIO pulsing while set. Start a function call. I prefer to work in ESP IDF. Yeah. Set direction, set low. What? Okay, maybe I don't know how to set these. Set level. Hang on. Is this sleep mode? Wait. ESP32 sleep mode. Hang on. Before entering light sleep, check if any GPIO pin to be driven is part of the VDD SPI power domain. That's different. Some IOs have internal pull-ups or pull-downs which are enabled by default. If an external circuit drives this pin in deep sleep mode, current consumption may increase due to current flowing through these pull-ups and pull-downs. So isolate the pin to prevent extra current. Call R... oh, man, I don't know. I think that's what it is. I think it's going to sleep and turning off the pin and then waking back up. And it's like, oh, the pin should be on. Okay, we'll do that. And then that's screwing everything up. But I lost track of time a little bit. It is almost 6:40 and I got to get out of here. So thanks for watching if you are watching. Thanks for tuning in if you're on the VOD. I don't know why you're doing that, but please leave a comment, like it. Let me know that, like, hey, whatever you're doing, I'm enjoying it somehow or another, or I like this or I don't like that. Give me some feedback. I can try to improve the streams if you help me out. But yeah, with that, I'm going to say have a good rest of the day. Thanks for tuning in. I will catch you on the flip side.